Okay, now we're recording. Perfect. So introduction to limits. So limits is a fundamental concept in calculus. It's one of the big things that we do. And it really is necessary to help us understand what a derivative is. A derivative is also a fundamental concept in calculus. But in order to really truly understand what we do when we start working with derivatives later this month, we have to talk about limits because limits is the foundation that we need. So what we're going to do is we're going to do an exploration. So what I asked is if you have your TI-84, and I'm actually going to make sure I can see myself in the camera. If you have your TI-84 calculator, please have it handy. If you don't have it, then just follow along, do the best you can. You could probably use Desmos perhaps, but I really want you to learn how to use this well because if things do return to normal in the spring and the AP exam is done the usual way, you can't use Desmos. You have to know how to use this. So I don't want it to be kind of a struggle or a pain if we're meeting a person or doing a hybrid model that I haven't really been using this in the fall. So I'm going to kind of ask you guys to really use this. So what we're going to do is we're going to type in this equation in our calculator. Now, just so you know, what you're typing in is a piecewise function. So before we actually type this in, let me show you what you're actually what this actually is. So it's actually three separate functions here. So it's like saying negative 1/3 x plus 5 if x is less than 3. So that's how you actually do a piecewise function in the TI-84 calculator. You do something kind of similar, I think, in Desmos. I can't remember exactly, and I don't want to figure that out during a video. I'll have to do it on my own time. But we'll just use the calculator because that's what I prefer right now. Then the next part will be negative 2 if x equals 3. And again, hopefully you have these notes downloaded. If not, try to download them right now and print them right now if you can. I am recording this, so no worries. You can always rewatch it later, or if you have a notepad, I guess. But it's easy if you have the template because you save yourself a lot of writing. And a negative 1/3 x plus 5 if x is greater than 3. So that's actually what we're going to be typing in the calculator. So you need to do, and actually I already have from the last class. So again, this is going to be more polished because I've done this already. If you hit, oh crap, I just cleared it. Okay, that's fine. That's okay because it's going to take you guys time to do it anyway. Okay, that's okay. I won't get too upset. So what you need to do, so here's the calculator, right? If you hit y equals is right here. It's the far left, top left corner. If you hit y equals, go and clear whatever you have. I did too, but I had the right thing. That's okay. And you're going to type in what you see there. Now, if you like, if you hit mode has a bunch of like different things here. If you go all the way down, you see where it says math print and classic. I have classic highlighted. The default's math print. Math print is the more recent operating system for the calculator. It's a good operating system because it does symbolic stuff. Like when you start doing exponents, it actually treats exponent like a superscript. When you're doing like square roots or logs, it kind of does those more properly. I'm switching to classic because I want to be able to see everything I'm typing under y equals. Now I'm under y equals, and right now it's blank. If I'm in math print, it's not going to wrap around the text. It's going to be hard to see everything I'm writing because it has a different kind of editor going on. So by doing classic, it actually wraps around all the text here, so I can actually see everything I'm typing in. So I'm going to type this in right now, and then show you what I have, and make sure you have the same thing. The one thing I need to do, hopefully I'll get this done over the weekend or early next week, is I do need to actually download the TI emulator. It's basically a program that shows an image of this calculator, and you can actually see me actually working it out. I just haven't got around to doing that. So and it's kind of a painful process because you have to get the cable and connect your calculator to the computer. But once I do that, that might make things a little easier, so you can actually see all the buttons I'm pressing. But I trust you know where y equals is, the top left corner, and go ahead and type that in. I'm going to type it in again as I see it. By the way, if you need to do the inequality symbols, you have to hit second and then math. That's where you can locate the inequality or the equal symbol. So all those mathematical symbols. So when you have to say x is less than 3, you have to hit second and then math. And then you can see that menu show up. It's called the test menu. And then you pick the symbol you need. So obviously I need less than 3. And the parentheses. Then I'm going to type in the next one. X equals 3. And I'm going to type in the other one. Negative x over 3 plus 5, parentheses, second math. So I need to hit x is greater than 3. Okay, I think I've got this correct. It looks good to me. Yep. Okay, so this is what I have. Your screen should look like this. Now, if you didn't switch to classic mode, then it's not gonna wrap around the text. You're not gonna be able to see everything. You just have to trust. You can kind of scroll left and right to see if you did it right. But that's everything I typed in my screen. Negative x over 3 plus 5, x less than 3. And you have to put all these pluses and parentheses. So the syntax is a little bit funky. You just have to kind of follow the rules. But it's all typed here as well in your notes. And of course, what is this function going to be? This is going to be a piecewise function. And it's going to look a little linear also. Well, not linear. It does look linear. This part right here, just cross this off. The part that says hint, like the conditional statement. Mrs. Blanford made these notes many years ago, and she was kind of explaining how the computer or how the calculator acts like a computer and how it classifies true and false statements. There are things called bits. Maybe you've heard of that. Like all microprocessors, even your cell phone does the same thing. It stores information as a bunch of zeros and ones. Don't worry about that. That will just confuse you. Just know that we're graphing a piecewise function. That's what I care about right now. Okay, once you have it all typed in correctly, if I hit the graph button, I get this. Looks like I get a line. But it's interesting because it's supposed to be a piecewise function, right? Like what it's really supposed to be looking like, I'll kind of do it off to the corner here. We're going to draw it on the bottom of this page. I'm doing a rough sketch, but it's supposed to look like this. That's what we drew. The calculator doesn't show that. It doesn't show a hole. It's supposed to be a hole at x equals 3, by the way. And it doesn't show a dot off in the yonder. But if I were to hit trace, sorry, second trace, if I were to hit second trace and typed in and then did option 1 value and did x equals 3, it now shows a little like x right there. So what I did was, in order to show that, I did second trace value x equals 3. So that way it shows you where x equals 3 is on the graph. It's not on the line, it's on the point, 3, -2, because I told the calculator to do that. You guys told to do that if you did this correctly. So hopefully we're okay with the graph. Any questions, or does anyone need a little more time to get the graph all established? Okay, and again, we're graphing a piecewise function. So if I kind of scroll down, see if I can somehow lasso this. What if it let me move it? It doesn't have that option. That's okay. You need to talk to people at Zoom so you can lasso and move things around, but that's okay. I'll just clear it. So again, the graph looks like this. Actually, I'll just redo it over here. And actually, if you're still working on the calculator part, that's fine, because I'm just going to take a little time to rewrite that piecewise function. Okay. So yeah, I mean, remember, graphing 1/3 x plus 5, y-intercept of 5, slope of negative 1/3. Yikes. Negative 1/3. So you go down 1, right 3, but there's a hole there because 3 is not included, and it's going to the left, but it's also going to the right as well. And there's a hole at 3, negative 2. Okay. Now, this is the exploration part. What we're going to do is we're going to punch in a lot of different x values. We're going to plug in x values to the left of 3 and x values to the right of 3. And we also want x to get close to 3. This is what a limit's all about. It's all about getting close. What is the limit? What is the approach? There are two ways we can actually streamline this process in the calculator. One way is you can actually treat it like f of x notation. You could type in the x value and have y1 right next to it. Another way is you can make a table in the calculator. I'm going to cross this off because I think this is a little more painful. It's not what I really don't like that process. I like this a little better. In order to do this, there are a couple ways you can get there. You're going to select alpha. Alpha is in the top left. It's a green button on my calculator. It might be a different color in your calculator. And you're going to then select trace. So right now, I'm in the graph. I'm going to clear the graph right now. The clear button's right here. I'm going to clear it. So on the home screen, you get alpha trace. This little window pops up. And it's a bunch of like y's, like y1, y2, y3, y4, y5, and so forth. I'm going to select y1. Why? Because my equation is stored under y1. So again, if you hit alpha and trace, then you should get something that looks like this. And then in parentheses, I'm going to type in 2.9. What this does, it actually evaluates the function at 2.9. So it treats it like f of x or function notation. If I hit enter, I get an output. The output's 4.03 repeating. So you should get 4.03 repeating. Now, if anyone's having any trouble with this, please let me know, because this might be a little bit new for some of you guys, especially because we probably didn't do much calculator work in the spring because we were in a pandemic and obviously doing remote learning. So, or you could plug in 2.9 straight up. You could do like, hey, negative 1/3 times 2.9 plus 5. You can actually do that, but that becomes very cumbersome if you do that repeatedly. If you keep typing that, you're going to drive yourself nuts. Then I'm doing negative 1/3 times 2.99, negative 1/3 times 2.999, negative 1/3 times 2.9999. That's crazy. Just do this. Just do alpha trace. And once you've done it once, right? So you have this right here. Once you've done it once, I could then just repeat my previous entry. To repeat previous entries, hit second enter. You hit second enter, so if it's second enter, it repeats your most previous entry. And then I could just change the input. Now my input's gonna be 2.99. And if you do that, I get a new output. The output's pretty close, but a little different. Now it's 4.003 repeating. So 4.003 repeating. And by the way, by the time I finish this exploration, I'm going to put you guys in breakout rooms because I think you guys do need a little time to work together, and my voice will need a break. Let's keep going. Let's do 2.9999. So it's 4.000. Repeating. 4.000. Sorry, those are zeros. Those are threes. Repeating. If you do 2.999999, like a bunch of nines, 4.00000, and 3 repeating. So I think it's pretty clear. Y is getting close to 4, right? That's what we're anticipating here. And look at the graph. Yeah, as I get closer and closer to x equals 3 from the left, we get closer to 4. Now let's do on the other side. Let's do 3.1, 3.01, 3.001, 3.00001. So if I do 3.1, so let's see here. Let me repeat it. So now we're going to be approaching from the right side. So now we're kind of coming at it from the right. So we're getting closer to 3 from the right side. You should get 3.96 repeating. Go to 3.01. Ah, come on. 3.996 repeating. Go to 3.001. 3.999. 6 repeating. It looks like we have how many zeros? 1, 2, 3, 4, 5. 5 zeros there. And a 1. It looks like I have 6 nines, looks like. So what do you think y is getting closer to as x gets closer to 3? Anyone can shout out.
4.
4.
4, there we go. And that's going to be the answer for this right here. So this is what we call a limit. So this right here is limit notation. What this means in words is all this. This is what this means. This means as x approaches three from either side, y gets closer to 4. So all those words can be expressed more compactly in this notation here. The LAM means limit. The x arrow 3 means x approaching 3. Fx is our function. And of course, because f of x is y is getting closer to 4. So it's all about approach, not what exactly equals. Because what was f of 3 exactly? It was -2. So apparently, f of 3 does not equal our limit as x approaches 3 for f of x. So Another thing we have to consider too is that we have to look at both sides. As we're coming from the left and coming from the right. So if someone asked kind of a good question, like in the previous class, when you have this, how do you know if it's positive or negative? You assume it's both. So you assume that you're coming at this from both sides. So from either side. Now there are something called one-sided limits. We're going to talk about that on the next page. And those look like this. We call this a left-hand limit. I probably should have color-coded this. But that's going to be as I'm coming down this way. As I'm coming down this way, that's my left-hand limit. This right here we call our right-hand limit. So what you guys just did without realizing it is that you've actually done left and right-hand limits. This is a left-hand limit when you plug in numbers close to 3, but from the left to 3, like 2.9, 2.99. Then you have a right-hand limit when you plug in guys close to 3 from the right side, like 3.1, 3.01, 3.001. We looked at this from a numerical perspective, and we saw numerically, yeah, y is getting closer to 4. We've now looked at this from a graphical perspective. Yeah, graphically, it looks like we're getting closer to 4. Even though at x equals 3, y is exactly -2, I don't care about that. I care about approach. That's what limits are about. They're all about approach. And I'm gonna beat that into you guys over and over and over and over again. That's all about approach. We kind of abbreviate this as LHL, left-hand limits. We abbreviate this as RHL, right-hand limits. And you need your LHL equal your RHL to actually find this number here. So the left-hand limit was 4, the right-hand limit was getting closer to 4. So we can say that the limit from both sides or either side is 4. So that's basically the numerical and graphical way of looking at limits. There are going to be some more advanced limits we'll do for sure. That's next week, where we'll use some algebra skills to figure those out. But always, 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 you could just do what we just did right now. Just plug in numbers close to what x is going towards. X is going towards 3, so plug in numbers close to 3 and plug on both sides, less than 3 and those greater than 3, and see what's happening to y. And hopefully they converge. If they don't, then we say that the limit does not exist. And that's something we'll talk about on the next page. But when you're going from the left, going from the right, we can call those LHL and RHL, and those must be identical for the limit to exist, to actually find the limit. So any questions about what I've talked about so far? No? Okay. We're going to explore this a little more in the next page. But before we do that, I think it would be good to do a little breakout room. In the breakout room, we'll be focusing on one of the worksheets. Let me kind of talk about that worksheet with you guys just for a couple minutes, and I'll put you guys in your breakout rooms. So I'm going to clear this. Again, this is all being recorded. So we are going to talk about parts of page 2 after the breakout room. We'll probably do it around 11:20. But for now, if you guys can pull up worksheet. So there are 2 worksheets that I wanted to focus on. Well, I was planning to focus on today, but we're only going to focus on one of them, and that's going to be worksheet 2. So here's worksheet 1, which I'm not going to do today because that's going to take me a while to kind of explain, and I think it might be a little too overwhelming because I'm already kind of giving you guys kind of a new concept with limits. You guys have covered power functions, but it's a tough concept. I'm going to do this as a video. Might be better to do this as a video anyway, so you can reference it. This will be a video that I'll have ready by tomorrow that you guys can watch anytime during the weekend or on Monday. And it'll be a Google form that goes with it, and I'll ask you guys to do these questions here and submit that. So that will be something you'll do over the weekend on your own. But instead, we're going to work on worksheet 2 today in the breakout rooms. So worksheet 2 is review from Algebra 2 and pre-calculus. In fact, sometimes some middle school programs talk about, transformation, even geometry talk about transformation. So hopefully there's lots of this review. We want to be very comfortable with transformations. We don't want that to be a sticking point. So let me kind of talk about what's happening in this graph here. So you have this funky graph. It's a piecewise graph, actually, right? You have a line here, another line here, another line there. So it's a piecewise graph. Don't worry about what the equation is. That's not a concern about it. The concern is, how do I transform this based upon these things I see here? So I'm going to do 1 and 4. Then I'll have you guys do the rest of these in your breakout rooms. So what I'd like to do is I like to kind of focus on maybe 6 random points here. And maybe make a little table off to the side. And have a few more columns going on here. So obviously the first point is -4, 0. The second point is -2, 2. 0, 2. Sorry, yikes. -2, 1, my bad. -2, 1, 0, 2, 1, 0, 2, -2, and 3, 0. Now what I'm going to do is for number 1, I'm going to multiply my y values by 2. So just get a little collaboration here. I'm just going to call on whoever I see right below me. So Millie, I see you, but right below me on the screen. So that third column, notice how all the f of x values I already wrote. If I'm multiplying by 2, what would that column look like now? And you're muted.
Oh, okay. So if you multiply by 2, then it's -8.
No, the y values, sorry.
Oh, sorry. Then it's 0, 2. Is that a 2?
Mm-hmm.
Yeah, 4, 0, -4, and then 0.
Great. So now what we do is we plot those points. And number 1, thank you, Millie. So you plot those points. And number 1, so -4, 0, -2, 2, and 0, 4. Then plot the other ones, 1, 0, 2, -4, and 3, 0. So notice how the graph got stretched compared to the original graph. It was a vertical stretch. So that's what you have to be able to recognize. Whenever you see a number being multiplied to the left of a function, that is going to cause a vertical stretch. You want to be able to recognize that quickly. So that's one of the transformations that we have to be comfortable with. Another one that I have to be comfortable with is something like number 4. Notice there's a +1. So you're taking the y values and you're adding 1. So let's do that. Let's add 1 to the y values. So Catherine, I see you next. So remember, our y values are in the second column. So now in the fourth column, I'm going to be adding 1 to them. So what would the fourth column look like if I'm adding 1 to all my y values? Go ahead, Catherine.
1, 2.
Oh, we had 2 Catherines. I'm sorry. Catherine Zoo, that's fine. I saw Catherine. Catherine Zoo, you're fine. Keep going. You're fine.
All right. 2.
1.
3. 1. -1 and 1.
Great. And you plot those points. So you're plotting your original x values with your transformed, that's what we call it, transformed. It's changed, your transformed y values. So -4, 1, -2, 2, 0, 3, and then 1, 1, 2, -1, and 3, 1. So notice how that graph is transformed, right? It went up 1 unit now. So this was vertical stretch by 2. This was shift 1 up. that's what's happening there. So you and a few people in a breakout room will do the rest of these transformations. So you have 2, 3, 5, 6, and you have 7, 8 on the next page. 7 are a little more challenging, but if you kind of approach it from what I did here, it's not gonna be too bad. You'll be okay. For number 2, you're multiplying y by -1. For number 5, you're multiplying x by -1. Or you can kind of think about, oh, negative flips over the x-axis or flips over the y-axis. Or like +1, you go up 1, down 1, or whatever, you know, you have all that stuff there. So it's 11:15, so we'll do this for about maybe 8 minutes. Then we'll come back, we'll talk about, and we'll have 15 minutes after that to wrap up the the parts of the 2.1 notes I want to do. So I'll stop sharing. Actually, I'll briefly stop this recording.